So you might hear the terms direct variation versus partial variation, and today we're just going to talk about the difference between these two. The easiest way to see the difference, I think, is by graphing them, or an example of each one. So you have your XY plane here, your XY plane here. I'm just going to show the top right quadrant, right? Because obviously this continues down here, down there. But let's just talk about the top right quadrant here, quadrant 1. A direct variation would be something that goes like this, that starts at 0, 0, right? Starts at the origin. You could also say that the y-intercept is at 0. That's another way to phrase that. Whereas a partial variation is something that's going like this, right? It starts not at 0, but at some value of b, right? Some number. So you could say the y-intercept is not at 0. That's really the only difference between a direct and partial variation. How else could we identify if it's direct or partial though? Well, if you're doing a table of values and you plug in 0 for x, you should get 0 for y, for direct. For partial, if you have a table of values and you plug in 0 for x, well, you're not going to get 0 for y, you're going to get some number, right? I'll call it b, because that's what we've been using. Likewise, when you write your actual equation for the line, y equals mx plus b, well, that b value is 0 for a direct variation, right? It's 0. So you just have y equals mx. Y equals mx. But for a partial variation, you will have y equals mx plus b, where b is a number. Okay? So let's look at some examples, and we'll try to figure out if it's a partial variation or a direct variation. So let's say I have c equals 300 plus 25n. So this is just some linear equation. Instead of y and x, we have c and n. That's okay, right? Well, this, we would say, is a partial variation because it has this number here that's attached, right? That's your b value. These are kind of switched around from how we're used to seeing it. Usually you would see it like 25n plus 300, right? Your mx plus b. In this case, instead of x, we have n. But there's that b value, the 300. So this one I would say is a partial variation. But if you have something like p equals, say, 3,600 times x, well, this is a direct variation because there's no additional term like up here that we add on. That's just a number, right? That term isn't there. So this is just a direct variation. Okay. Now, what about the terms consistent system versus inconsistent system? Sometimes you'll hear it said as consistent system of equations or inconsistent system of equations. But what does this mean? Well, a consistent system means that you have at least one solution. Now, what is a solution? What does that mean? Well, what it means is you have a point of intersection between two lines, right? So that would mean that an inconsistent system has no solution, right? Or no points of intersection. So how could two lines not intersect if you have two lines on a plane, right? Because if you have a line that goes like this, another line, if you go far enough to the left or to the right, is going to cross over with this line, right? Unless you have parallel lines, right? You have another line that goes like this. And to show the parallel, you can draw these little arrows like that. So these two lines would be parallel, and therefore there's no solution because they never cross. Whereas a consistent system, right, a system that has at least one solution, would look something like this. You'd have a line that's going like that, and then a line that's going like that, and then you can see they cross at some point. But a consistent system says at least one solution, so it doesn't have to be one, it can be more than one. So how could you have multiple points of intersection, right? How could you cross at more than one point when you're talking about two straight lines? Well, it could be that the two lines are directly on top of each other. So that's one line, and then there's another line, right on top of it like that. So it's kind of hard to see because they're right on top of each other. But those two lines are exactly the same. And so if those two lines are the same, what we call that is a dependent system. Dependent system. And what that means is you have infinite solutions. infinite solutions. Why are there infinite solutions? Because it crosses everywhere. They cross here, they cross here, they cross here, they cross here, they cross here. They touch each other everywhere. At every point, one line is touching the other line. Over here, we say it's an independent system. And it's independent because there's only one solution. One line is not dependent on the other line. They're both doing their own thing. They just happen to cross at one point in time. These two are dependent because they're exactly the same. They're dependent on each other, and therefore they touch at every point. So there's infinite solutions.